Hello, my name is Raidu Jagat. Now I am here to discuss one question from time speed distance concept related to CAT previous year questions and having a difficulty level of 2 to 3. And I try to solve that by using ratio method. Now I share the question. One second. Okay, here in this question, a car travels a total distance of 150 kilometers. After traveling a part of the distance without any trouble, then develops an engine problem and proceeds with 2/3 of its former speed. Earlier speed is okay, 3 parts. Now speed is 2 parts. Engine actually it is moving with scheduled speed. Under that condition it will be scheduled in scheduled time. For example, if throughout this problem we will consider with distance is equal to speed into time concept. When distance is fixed, speed and time are inversely related. Speed and time are inversely related. Why? Because S and T are multiplied. So when speed increases, time taken will be reduced. When speed decreases, time taken will be increased. That means increased speed means delayed time. So here speed is decreased to 2/3 of its former speed. Former speed is nothing but scheduled speed, actual speed. And speed is decreased from 3 parts to 2 parts over the distance. And therefore arrives the destination 48 minutes late. So time taken will be in the ratio 2:3. Earlier speed ratio is 3:2. Speed ratio is 3:2. Time taken should also be in the ratio 2:3. So actual time is 2 parts. Now taking time is 3 parts. It is a delay of 1 part. 3 minus 2, 1. So I apply all these concepts in the problem now we are going to discuss. This is A, starting point. This is B, 150-kilometer point. Assume 150-kilometer point. Here up to A dash there is no fault in the engine. So it moved. A to A dash is the actual distance moving with some particular speed, scheduled speed S, and it will take some scheduled time part of A dash. Okay. Now at a fault occurs. So here at a fault occurs. Speed ratio will be 3:2. So time ratio will be 2:3. Time ratio will be 2:3. So if it is moving with scheduled speed of 3 parts, it will reach the destination B in 2 parts time. Because of reduced speed to 2 parts, it reaches the destination in increased time 3 parts. That 3 minus 2, which is nothing but 1 part. 1 part is nothing but delayed time. Here in the first case, the delay was 48 minutes late. Delay 48 minutes late. Therefore, 1 is corresponding to 48 minutes. So if 1 part is 48 minutes, what about 2 parts? 2 parts is nothing but actual time. When speed is 3 parts, 3 parts is actual speed. So 2 parts will be 2 into 48, 96 minutes. This is actual time taken from A dash to B at scheduled speed. And 3, what is this 3? 1 part is 48 minutes. 1 part of time is 48 minutes. 3 parts of time will be 3 into 48, 120 plus 24, 144 minutes. This is delayed time, including actual, okay, total delayed time. Now, instead of fault occurring at A dash, if fault occurred at 24 kilometers from this point, excuse me, 24 kilometers from this point. So fault occurs here. Under that condition, this is A double dash, assume. So here, I repeat, actually it is moving from A to B. At A dash, fault occurred earlier. Now at A double dash, fault occurred. If fault occurs at A dash, scheduled time, okay, original time taken will be 96 minutes. That is fixed. We have to remember this point for the next step. And coming to second part of the question, when fault occurs at 24 kilometers from the earlier point. Earlier point is A dash. Now fault occurs at 24 kilometers from further. 24 kilometers further from A dash. So A double dash. So at A double dash, speed ratio will be again from A double dash to B, speed ratio will be 3:2. So time will be again 2:3. Time ratio will be. Now the car would have arrived 12 minutes sooner. So that means actually at B it is reaching 48 minutes late because of fault occurring at A dash. Now because of better speed, because of fault occurring at A double dash, that means with scheduled speed it reached from A to A dash to A double dash. Therefore, delayed time will be 48 minutes earlier, 12 minutes sooner, 48 minutes 12, 36 minutes. Again, it is a delay of 36 minutes. Therefore, 1 part to 3. 3 minus 2 is nothing but 1 part. This 1 part is equal to 36 minutes. So, 3 parts will be 3 into 3, 96. 108 minutes will be the delayed time. And 2 parts will be 72 minutes actual time. Time taken from A dash to B. I repeat clearly. Fault occurs at A dash. Delayed time is 48 minutes. So one part is 48 minutes. Three parts will be 144 minutes. Not required for this problem. And 2 parts is scheduled time from A dash to B, 96 minutes. This is scheduled time from A dash to B, 96 minutes. And if fault occurs at A double dash, 3:2 will be the speed. Time will be 2:3. 3 parts, 108 minutes will be the delayed time from A double dash to B. But 72 minutes, which is nothing but 2 parts, related to 3 parts of speed, actual speed. So 72 minutes will be the actual time taken, scheduled time taken for A dash to B. So if we observe this 24 kilometers is covered during that time 96 minutes minus A dash B 72 minutes. I repeat clearly. A dash B, that means this point to this destination, it took 96 minutes. A double dash to B, it took 72 minutes. So in between the distance is 24 kilometers. So 96 minus 72, how much? It is 24 minutes. So 24 minutes is covered over a part of 24 kilometers. So what is the speed of that car? Scheduled speed. Speed of the car will be 24 kilometers divided by 24 minutes. 24 minutes. 24 kilometers by 24 minutes. 24 minutes. In other words, we can say 60 kilometers will be covered in 60 minutes. Or else cancel 1 kilometer by 1 minute. 1 kilometer by 1 minute will be the scheduled speed. So 1 km by 1 minute is 60 minutes, 1 by 60 hour. Therefore, 60 kilometers per hour will be the scheduled speed of the car. I repeat, 24 kilometers are covered in 24 minutes. 60 kilometers will be covered in 60 minutes. 60 minutes is nothing but 1 hour. Therefore, directly you can write it as 60 kilometers per hour is the scheduled speed, actual speed of the car. That is, find the original distance it traveled without any problem and the speed over that part of the journey. Speed over that part of the journey is 60 kilometers. Therefore, answer second part is 60 kilometers per hour here. But for justification, I do the first part also. So I do. So A dash has to be found. A double dash is equal to 24 kilometers and A double dash to B it is covered in 72 minutes. So actual speed is okay. From this we can say 24 kilometers are covered in 24 minutes. Therefore, 72 minutes is corresponding to scheduled time. Therefore, 72 kilometers will be the distance A dash to B. 72 minutes is taken by car from A double dash to B when it is moving with scheduled speed. Therefore, A double dash B is 72 kilometers. So 72 kilometers is the actual distance. 24 kilometers is the gap. Altogether, it is 96 kilometers. 96 kilometers. but total distance is 150 kilometers. 150 minus 96, it is equal to 20, okay, sorry, 54 kilometers. So A dash is, this part is 54 kilometers. If we observe, the car it traveled without any problem for this part of the distance only, A dash. So A dash is 54 kilometers. For this part, it is moving with speed 60 kilometer per hour and covered a distance of 54 kilometers. So answer to this question is 54 kilometers and 60 kilometer per hour. Option D. Here, if we observe in this problem, distance is equal to speed into time. Speed and time are inversely related or applied. For explanation purpose, it took this much time, but for solving, if we are having good practice, number of steps can be eliminated and we can go to the answer 54 kilometers and 60 kilometers per hour directly. Even though it is a theta question, even if it is a theta question, we can answer this question. Thank you. If we like this video, please share and thumbs up.